everybody. Welcome to Quarantine Lab number 6. I'm actually looking at this on my phone, and I just got this funny idea. I wonder what would happen if I filmed the film. Oh, it's not exactly live. That would be funny because you should see into infinity, right? If the camera was filming what the camera was filming.
The whole fractal thing, yeah.
All right, well, that was just something fun I wanted to try. Anyhow, tonight we're going to do something that's super simple, really cool, and very open-ended like a lot of the stuff that we do. We are going to build electric motors. Now, when I was a young lad, I had at least 10 build-your-own electric motor kits, and I had at least 10 of them that didn't work at all, and it drove me crazy. Tonight we're going to show you how to build the simplest electric motor that works just about 100% of the time. Now, if you like this, you get this motor to work, there are dozens of different ways you can do it. Motors are pretty ingenious little devices. And motors require mainly two things. One is some magnets, and the other is a source of electricity. Now, this is kind of a mind-blowing thing to think about, but magnetism and electricity are actually the same thing. If anybody's ever pulled like a woolly blanket over your head in the winter and you get that static cling and your hair stands up and the blanket sticks to your hair, your clothes stick to your body when you take them out of the dryer, static electricity, we all know that. Exact same force behind static electricity that's behind why these little magnets stick to each other. And the big key, and some of you will already know this, when you're dealing with magnetism, is opposites attract. So I have this whole stick of these little neodymium magnets, and each magnet has two ends, a north pole and a south pole. If I try to put two north poles together, I can't do it. But north and south stick like that. Now, tonight, if you have received your DIY Sci Kit, you're going to want to get your hands on the two little silver neodymium magnet discs that are in there. These are the best for this. If you don't have those, don't be alarmed. You can use just about any magnet in your house. You can use these little guys that also came in the DIY Sci Kit, although the neodymiums are the best for it. You can use a refrigerator magnet, a little disc magnet, any kind of magnet you have around should work for the motor building tonight. I'm going to show you a couple different ways to do it. But first, we're going to get started on this whole why is magnetism the same thing as electricity. And this is another thing. If you have your DIY Sci Kit, grab your Petri dish and grab your little tiny vial of iron filings. It's a little Eppendorf tube, little cone-shaped tube that has the iron dust in it. Now, if you don't have that kit, but you have your nail, your screw, or your bolt, and a nail file or a piece of sandpaper, you can make your own iron filings, because iron filings are just something made of iron that has been filed. So you can make iron filings simply by filing with, I have a big double cut metal file, but you don't need that. You can use a nail file. You can use the little file that's on the end of the nail clippers that you probably have in your house. And you can just kind of shave some of the metal off of, and it's going to be hard for you to see, but I've already got some little flakes of metal in this dish. You can just start to file that metal until you have a little pile of it. I'm going to dump some of my iron filings in here just to save a little bit of time. I didn't drop a whole lot in there. These guys are cool in the Petri dish because you can actually use them to see the invisible magnetic force field. And if I put the magnet underneath, you can see how they move. Drop those. Luckily, I have dozens more on me. You can actually see the metal flakes move in response to the magnetic field. I'm not even touching the bottom of the dish because that's how strong these guys are. So there's the invisible force field around these magnets. And we are going to use electricity to make our own magnets. So keep that dish handy. And this is where you're going to want to get your copper wire. Now, we said in the directions you want enameled copper wire. This looks like a thin strand of plain wire, but it actually has a really thin coating of insulation. It's almost painted on that keeps the electricity from escaping the wire, and that's very important. The first step is going to be to remove a little bit of that insulation so we can hook it up to our battery. But I do want to show you before we get going, you can find this stuff everywhere. If you have any kind of junk electronic stuff, you're guaranteed to find some ream of copper wire. This is from an old computer. This is from an old television. This old drill that I have here that we're going to get to later. If you have an old broken drill, the motor is just chock full of that stuff. So if you're worried about where to find some enameled copper wire, it's pretty easy stuff to come by if you know where to look. So go back through the recording later on if you need to go get your hands on some enameled copper wire, and try it again when you get it. This stuff is generally pretty thin too, so it's pretty easy to work with. So I have a pretty long strand. There were 2 strands that came in those DIY side kits, which by the way have all been shipped out as of yesterday. The last handful of them went out yesterday. So if you didn't get it today, it should be here any day now, or at least what we had as of yesterday has gone out. You want to take either your file. I'm going to use a pair of scissors, but that's because I have been cut so many times it doesn't affect me anymore. If you have your little nail file or a little piece of sandpaper, first step is going to be to take some of that enamel insulation off the very end of your wire, because we actually want the electricity to be able to get in here eventually. So see, I'm scraping that off. I don't know if it's very clear on the camera, but this is kind of a red enamel wire, and you can see where the bare metal has been exposed. You're going to do that at one end and then flip it around to the other end and repeat the process. Now I'm actually just kind of holding it under the corner of the file, or holding it right up against the teeth of the file and pulling it through. Doesn't take a lot of force. Sometimes you can actually rip the wire. It's pretty light stuff, so don't go too crazy. You just want to make sure you expose the bare wire so that when we hook it up to the battery, you can get your electricity on in there. Batteries, while we're talking about those, really doesn't matter what size battery you have. We put in the directions a AA, a AAA, or the C or D, which basically just look like a bigger AA. The round ones are the best. If you have one like a 9-volt or one like this, you can use them. They're just, when we get to the motor building, it's not going to be as easy to hook up. Now tonight I might use this big battery just to demonstrate some stuff, just because it's easier for you to see, but either one of these guys will work just as well. And the first thing that we're going to do to get our heads around this whole electricity and magnetism thing is we are going to make a simple electromagnet just to show you how electricity can be used to generate a magnetic field. Now this is something that some really brilliant people back probably in the, let's say it was in the 1800s, figured out that anytime you have electricity flowing through a wire, it creates a magnetic field. And if you just have electricity flowing through a straight wire, it creates a really weak magnetic field. But if you wrap that wire around something made of metal, particularly iron, you can amplify that. So if you get your metal or your steel nail or bolt, first step we're going to do is we're just going to make sure you have some wire sticking out, hold it down on there, and we're going to start to coil it around our nail. Now, this is interesting because electricity is a flow of electrons, and electrons are mainly what is responsible for our magnetic force. Inside of a permanent magnet, like these neodymium magnets or like these little ferrous bar magnets I have, the matter, the iron that makes those up, is also composed of electrons, and those electrons are spinning. And the electrons in any matter are spinning all the time. What makes a magnet unique is the electrons are all spinning in the same direction. So a long time ago, we discovered that if you take wire and roll it around an iron object repeatedly in the same direction, and then plug it into a source of electricity, you end up having electrons that are going in a circle in the same direction. So you've got a way to induce magnetism in something that previously was not magnetic. And I will prove to you before I hook this thing up that I'm not cheating. This is not a secret magnetic nail that I'm using that you didn't know about. So I've got my wire wound around my nail. I've got the 2 ends exposed because we're going to need them to connect to the battery. And I do want to show you very quickly that under my iron filings, you'll notice no magnetic field there. Now, like I said, just for simplicity's sake, I'm going to use this big battery just so I can keep my hands free. But for you, the next step you're going to want to do if you have one of these smaller guys is get one end on each pole of the battery and hold them with your fingers. Now what I'm going to do is I'm going to wrap it around the terminals here just because it's going to be easier for me to do this with 1.5 hands. And so now I've got this guy hooked up to my source of electricity. Check out what happens to my iron now. You see the magnetic field that's formed? I'm moving those filings around very easily. So just by getting electrons to stream around something in a circular pattern in a coil, you can generate a magnetic field. Now, that's pretty cool in and of itself, but we're going to take that a step further. Let me get this disconnected. There we go. Also, key, if you've made an electromagnet successfully at home, do not leave it connected to the battery for long periods of time because they will start to warm up. And we've essentially created a really big short circuit. We'll get into what a short circuit is perhaps on a future video. But if you leave this thing hooked up to your battery all day and all night, eventually this is going to get really hot. The battery's going to get really hot. The battery can blow up. The battery can melt down. It'll start to leak. You don't want to mess with that. So disconnect it when you're done using it. If you start to feel it get warm, disconnect it. Let it cool off for a little bit. Shouldn't be a big danger, but be safe. Use your head. Be logical. We can do this. You're all good at this stuff. So we've created a magnet by causing electricity to flow in a circle around something. But us humans, always thinking, decided to take that a step further, and we realized that we can use that magnetism to create motion, particularly spinning or circular motion. And that's where the electric motor comes in. An electric motor is basically just an electromagnet that is being forced to move in the presence of a permanent magnet. So we're going to build a very simple frame for our electric motor, and then we're going to get into building our electric motor. We're going to use the same copper wire for what's called the rotor of our motor, the spinning part. But to build the frame, you take a paper clip, stretch it out, open the whole paper clip up, and then just kind of bend 2 hooks in your paper clip at the end. So I got a straight paper clip, and I'm going to bend it down and hook it like that. You see what I've done there? Very simple. And then I'm going to stab it into this piece of styrofoam packaging I had laying around. If you don't have a piece of styrofoam packaging, stack up a couple pieces of cardboard. That'll do the same thing. Or you can even bend this and put a piece of tape on it, like yay, to keep it up. So a couple different ways that you can make this base at home with pretty much anything you have laying around. Now you're going to want it to stick up as much as possible. It's in there pretty firmly. We should be good. Now, this is key. Take your battery, press one terminal of your battery up against your paperclip hook, and then go ahead and make a second paperclip hook. Here's probably the trickiest bit of this, or maybe the second trickiest bit. You're going to stab your second paperclip hook in right at the other end of the battery. Now, if you've got a little wobble in this and they're not staying connected, something really simple you can do. Snag a little bit of tape and just wrap a nice big piece of tape from one end to the other to hold those paper clips up against the battery. Not only are these paper clips going to be what hold our motor up, these paper clips are going to provide the source of electricity to our motor. So now I've got my battery taped in there so I know my paper clips are firmly against the contacts of the battery. Now, the next thing I'm going to do is I'm going to try and line them up so that these 2 hooks are about even with each other. It looks pretty close. I could probably get it a little closer if I fiddle with it for a minute, but just for the sake of experimenting, we're not going to mess with it a whole lot more. Now, this is where we make the moving part of our motor. And again, the moving part of the motor is basically just an electromagnet that's capable of spinning. You've already seen how to make an electromagnet. You make it with circles of wire, loops of wire, coils of wire. So I'm going to get another piece of copper wire from my my junk electronic appliance, and if you're using your DIY Psy kit at home, you should have at least 2 of those in there. I have fat fingers, so sometimes when I grab them, I put more than 2 in there, but you should have at least 2 little spools of wire inside your thing. So go ahead, open another one of them up. I'm probably going to have to do a little cutting here because I've got quite a tangle of this stuff. And if you've got your wire opened up, go ahead on to the next step, which is going to be clean the ends off of it, just like we did in the last experiment with the electromagnet. So you're going to want to make sure that you have the enamel or the insulation cleared off of two ends. So again, use your sandpaper, your nail file, whatever you've got handy. Be careful not to cut yourself, not to scrape yourself up, and clear off that coating from the ends. Managed to cut a piece of wire that's far too short. If I had realized this was this tangled, I would have gone ahead and done this right there. Oh, surprise, I have another piece right here. So I'm just going to open that one up. And we're going to get it nice and straight. And we're going to clean off both ends of it. And again, that wire is pretty fragile, or it can be very fragile. So take your time. Don't stress it too much. Don't pull it. Don't tug it. Usually it's light enough you can cut with scissors, as you've seen me doing. So I've got my wire nice and straight. And then I'm going to go ahead. I'm going to clean off the insulation. Probably about, probably going about 2 inches back. I'm cleaning this insulation off the wire. You get it off of both ends. And there we have it. Nice, clean piece of wire with the ends exposed to electricity. Now, we said an electromagnet that spins will make a motor. But we don't want to leave our piece of iron or steel in the middle like we did with our simple electromagnet. So we're going to use something else to wrap this into a perfect circle. One way you can do this is to take another battery, or take your first battery. If you want to take it out and reuse it, you can do that. We'll put it back in later. I'm just going to use this plastic tube that I have handy. Anything small, anything that's about as big around as your finger, but it has to be a perfect circle and hard. I've seen kids do it with a marker. You have a marker, you can use that. I've seen some people do it with a pencil. They can get a little heavy, but it can be done with a pencil. And the first step is you're going to leave all the clean end of the wire sticking out. So go to where you cleaned the wire off. Mine's right about there. Put a finger on it, and then we are going to start coiling it up. But your coils need to be nice and tight and neat. So I've seen occasionally some people do it like this, and you get this sloppy mess. It's going to be all out of balance, all off weight. It still will probably work, but it's not going to work very well. Also, something that'll make your motor a little more stable is I'm putting some turns of wire on this side. I'm going to hold the whole thing and go over to this side and make a few coils. And just to speed it up, I'm going to turn this as well. Switching sides, keeping my coils nice and tight. So basically we're making a little electromagnet with sort of a stick hanging out of it. Now, when you get to about this point, when you have maybe twice as much wire sticking out as you started with, sticking out, gently slide the whole thing off and catch it so it doesn't unspin itself. Now, this is going to be another crucial part of this whole ordeal. And this is where a lot of people, I don't want to say fail, because there's no such thing as failing in science. You're learning what doesn't work. But where they immediately learn one thing that doesn't work is in this last step. So you want one end of this wire sticking out this side and one end of this wire sticking out the other side so that we can place it in our brace. So take the rest of your wire, bend it over here, and then for good measure, wrap it down inside your coils and pull it out. And if you have enough wire to do it, wrap it down inside a second time. So we're kind of twisting it around here. And this is going to hold this whole apparatus together so it doesn't unspin itself immediately. Now, I want everyone to pay very close attention to this bit, because this is also mission crucial. This thing has to balance real nice. See, mine's a little heavy on the bottom. If I turn it like this and let go, that side sinks. So I'm going to move my wires closer to the bottom. Now it's kind of hanging flat like that. So I'm going to bend my wires down again. That's looking pretty good there. It might still be a little heavy on this side. So you're going to have to fiddle with this a little bit to get it balanced as perfect. That's pretty good there. Almost as perfectly as you can. Now, we're about to put it into the base here. But before we do that, you're going to want to grab your neodymium magnet discs. And again, if you don't have neodymium magnets, refrigerator magnets, any kind of magnet you have should work for this. And once you have them in your hand, now I'm holding like 6, 7, 8 of these things just because I want you to be able to see them on camera. You've got your wire cleaned off, stripped off as much of that insulation as possible. I actually just saw a spot I missed. Getting sloppy here. Okay, nice and clean. You're going to put that in your motor base and just give it a little spin. It should spin freely like mine does. Now, electricity is coming up from one end of the battery, passing through the paperclip into the motor, going around and around and around these coils and creating a magnetic field, and then going back down here into the positive end of the battery to return. This is a little floating electromagnet right now. And what we're going to do, keep in mind, opposites attract. So one pole is a north, one pole is a south. We're going to point one pole of our neodymium magnets at this thing and give it a little spin. And it stopped because I'm out of balance here. So I'm going to drop one side a little bit. I'm also very heavy. I'm going to try a little lighter one. I made this a little bigger than I probably should have just to show everybody what was going on. So I have one that's really, really thin and light. And again, I have to balance this bad boy. All right, so we're in. Now you need to hold your permanent magnets pretty close to this thing. Failure. And you're going to give it a little spin to get it started. And what's going to happen is the north pole of your electromagnet is going to be attracted to the south pole of your permanent magnet, which is going to make it spin around towards your permanent magnets. As it spins, it's going to have too much energy to stop. You can see it kind of going crazy already as I get my magnet close. So as it spins towards my magnet, it's going to have too much momentum to stop itself. And it's going to spin over, and then the north pole is going to point towards the north pole, which is going to make it repel, which is going to make it continue to spin. Kind of like the pedals on your bike, how one foot's pushing down, the other one's coming up. Oh, she wants to spin. Let's try again here. I'm going to put my permanent magnets here and flick it with this one.
I think that side's a little higher too.
Yeah, and so another key here is balancing this thing. If these two wires are nice and level,
Yeah, drop that one down a little.
and this thing here also has to be as perfectly balanced as possible. Another troubleshooting measure you can look into is, did you clean the wires well enough? Did you get all that insulation off of them? So if you have any doubt, go back and clean these little strips again, just to make sure as possible that you're getting electricity into the thing. I have had lots and lots of experiences where I was building this with groups of young scientists, and they had these beautiful, perfectly balanced motors that looked like they should spin, and they didn't do anything, and they were like going crazy. Why won't it work? And it was because they didn't clean the insulation off of them. There we go. Oh. So I hope everybody caught that. It just spun so hard that it actually flipped out of the base. So again, lighter wire is going to be easier to get going. It's also going to be a little harder to control, but it's really good wire for building your first motor or two. And then once you get better at it, better at the design, maybe move up to some thicker wire, try a different design. And there are literally dozens, maybe more ways that you can design these. You can make them with a rotor that has a paperclip as the base and arms that stick out with electromagnets on them. You can make them out of, anyone has Legos and Neocube magnets at home, you can make your electrode, your little holders literally out of little magnets.
You want to try that base?
I don't have a battery for it. So. Just had some stuff fall over there. So again, don't give up on this easily. It's very simple to adjust. It can also get very frustrating. Now, obviously, I've done this in a big hurry here because I wanted you all to see it. Getting it balanced is the trickiest bit of the whole thing. I just had it going. I had it spin so fast that it fell out of the apparatus we had built to contain it, so I know it works. Again, the key is getting these wires perfectly lined up and then getting it in that base. That looks pretty good there to me. Ah, it spun out again. It's so easy to bend these delicate little wires. You got a couple turns out of it there. Tell that's not balanced already. I like that. Another good way to make this thing go for sure is to take a bigger battery. So I'll get that bigger motor that we started with here in this thing with the bigger battery. And I know I'm getting electricity because I just saw sparks. I'm going to give that a little spin, get my magnets in here. And when it's working, I can actually feel this thing bumping these little magnets in my hand. And there we have it. So every time this motor spins around, it actually delivers a little jolt to not an electrical jolt, but a little thump into these magnets, because the force of the spinning electromagnet, I wonder if that's enough field there. So the force of this thing spinning when it repels pushes away, and when the opposite side comes towards me, it pulls it in. So you should be able to feel if your motor is working or beginning to work, because you'll actually feel this like invisible little punch into your magnets.
I was going to say, I hate to bring it up too, but that's a generic battery, and I don't want to, talk about brands or anything here, but
yeah,
we've had some bad luck with generic batteries sometimes.
I know that this one works right now because I just saw sparks on my base when I put it in, and we just had her spinning pretty nicely.
I'm saying the little battery.
So I would like to show everybody something else before we wrap up for the night. And you see, I'm falling into this. I already know this works. I just had it spinning. You all saw it. I had them both go for a little bit, but it's kind of hard to stop once you get started. Oh, I want to make it go again. And that's why we're doing this one tonight. Like I said, when I was probably about 9 or 10 years old, I got a motor kit. It didn't work. I built it. I rebuilt it. I tried new batteries, tried an electric transformer, all kinds of different power sources. Didn't work. Got a different motor kit, built it. Didn't work. And I did that probably 20 or 30 times until somebody showed me how to build these simple little things. And you can get these to work just about all of the time because of their, look at that. See, I had it stuck up there, so I know that's my opposite pole because it's kind of attracted to the one side, not the other. There she goes again. So I want to show everybody something else that's kind of cool. And I think, first of all, take this off of here. Don't leave it on there because, again, you've got a battery hooked up to some wire that can short circuit. That battery is actually already a little bit warm. This one is too. So if you're done using it, disconnect it because you don't want your battery to burn up or blow up. Something cool I'd like to show everybody though. So we said electricity and magnetism are effectively the same thing. Same force, you see it in a different way. So this motor here has this drill has a motor inside of it. And I've gone ahead and just welded a crank onto the nose of the drill. And then I took the battery out so I can see the two battery contacts, and I have them exposed here. I am going to put my alligator clips on those battery contacts to demonstrate something really cool about this whole electricity magnetism thing. I want you to think about this anytime you turn on a light tonight. Where does my electricity come from? Well, since electricity and magnetism are the exact same force, you can take a motor, put electricity into it, and have it move. If you take a motor and instead of putting electricity into it, you make it move by yourself or using some other force, you can actually make the motor produce its own electricity. So, if I put a battery on these two wires, it would make my motor spin. But since I'm making my motor spin, it's cranking electricity out the back side. And this is how electricity is generated. I know you probably hear on TV all the time about hydroelectric power. If you can have a waterfall spin a wheel that's connected to a big motor, it makes electricity. Right now, a lot of the ways that we generate electricity are burning fuels like coal or oil, and they generate steam pressure, which makes a big steam turbine spin, which spins a motor, which makes electricity. So there are lots of different ways to use this idea right here. Even if you were to disconnect that battery, put your little motor on here and hold the magnet up and spin it, and you had a meter, it would actually generate a small bit of electricity going back. So these things are pretty cool. They're very, very old technology. We've known about them forever, but they're still super, super useful. And like I said, there are dozens and dozens of ways you can experiment with this, modify this, change this, make it better, make it different. So check it out. There's a lot of stuff online if you want to look at it. There are a lot of really cool little kits out there. I think this cost us a couple bucks.
Maybe
You
$5.
pop your battery in the back end of it. You put your motor right on these two clips. The magnet sits right there. Pre-made motor base for you there. And then you can build all kinds of different designs. If you look around online, you'll see lots of ideas. If anyone has questions, you know where to come. We're here all the time. Email us, call us. Happy to talk to you. We will see you all next week for something that we still haven't decided upon, but it's going to be a good one. So everybody stay safe, stay sciencey. Till next week.